Okay, this is the last section of Unit 5, and it is about correlation, which we mentioned that in the last section, 5.2, and we're going to get into it more today. So just a little funny joke here, correlation. These are obviously apple cores, and they're related. This is grandpa apple core, and maybe mom apple core, and dad apple core, and a baby apple core. So it's they're correlated. Correlation. Get it? Get it? Okay. All right. Moving on. This problem should look familiar. It was on the last. I think it was maybe on the wrap up on the last one. Yeah. And I had you use the equation of best fit to predict some different numbers. But now what we want to do is we want to talk about the slope and describe what it really means. So the slope of it can be pulled right from that line of best fit because it is a straight line. We know it's a linear equation in slope-intercept form. So that's y equals mx plus b. So we're saying that our slope is negative 2.25. Well, we know that slope is rise over run, and rise deals with the y variable, run deals with the x variable. So negative 2.25 we can make into a fraction. It's weird because it's a decimal and a fraction, but it'd be negative 2.25 over 1. We can always put a number over 1. Well, that top number then is your rise. The rise deals with the y variable. So if you can read that, you might be able to read it better on your paper. That is your semester grade. Okay, it's your percent. So we're saying it's negative 2.25%, and the 1 would be the number of missed classes. So to put that into a sentence, the slope means, I'm going to make this font smaller so it fits. The font means, the slope means you lose 2.25% for every one missed class. Okay, so that's what I'm looking for when you're describing the slope. Just a quick sentence. The slope means, and what does it mean? Talk about your rise per whatever your run is. The y-intercept is also given. It would be 85. Your b is 85. And what does that mean to you? Well, keep in mind that the y-intercept occurs when your x is 0. Our x is our missed classes. So if you don't miss any classes, you would be expecting a score of 85. Okay, so just a quick sentence to say that. The y-intercept means if you miss no classes, you can expect to earn an 85%. So quick sentence describing what your slope is and what your y-intercept is. Okay, Sully says the line y equals negative 11 over 4x plus 83 would be a better fit. What do you think? Well, you could graph this. Just be a little bit underneath that one. Use a different color. Be a little lower here. And it would be negative 11 over 4. Well, that's still negative 2.25. It's just in a different form. No, that's not true. It's negative 2.75. So it's a bit of a different slope. So who would you think, this line that's there or this line that would be written here would be a better fit? And the answer is there's a mathematical way to figure it out. And it involves something called the correlation coefficient. It's an R value, which means we use the letter R to represent it. It shows the strength and direction of your scatter plot. So remember in the last section we talked about strength of the scatter plot, whether it would be a weak correlation, a strong, or a moderate, and we talked about whether it was positive or negative. So this correlation coefficient, this R value, it's going to assign a number to that. So it takes it kind of one step further than what you did in 5.2. Okay. It is some number between -1 and 1. Okay, so we say that R is between -1 and 1. If it is 0, right in the middle, then that would be a weak correlation. If it's either endpoint, either -1 or +1, it's strong. And then, of course, somewhere in the middle would be moderate. Okay. Do I have something written here? Where's it at? Over here. Let me get rid of this again. So strong might be anywhere from plus or minus, whoops, 0.7 to plus or minus 1. That's going to be a strong correlation. It's going to be a moderate correlation if it's plus or minus maybe 0.3 through 0.7. And then it's going to be weak plus or minus 0, well, I guess I don't need plus or minus for 0, through plus or minus 0.3. Okay? The positive and the negative is just saying whether it has a positive slope or a negative slope. Okay, so that part doesn't affect whether it's strong or weak. That's just saying what type of slope it has. So if we have a scatter plot that looks like this, almost pretty much a perfectly straight line, that's going to be, and it's positive, that's going to have a correlation coefficient of 1. If we have one that's kind of generally pretty close to a straight line, that might be more like 0.7. Maybe you have one that has let me get rid of this one because that doesn't look so good. You've got something happening here that looks like it's going to be a positive, but it's not strong, it's pretty weak. Then this might be maybe just like a 0.1 or 2, a very small number. Okay, so those were all positives. You can also do the same things with the negative. So maybe you have a weak negative correlation. So that would be R equals negative, maybe 0.2. You could have the moderate. That's pretty close. That looks like maybe a point oh, I did positive. I want to do negative. Let's fix that. A negative 0.8. Okay, and then all the way to a very strong scatter plot, a strong correlation of a solid -1. Okay, so you can have decimals on all of these. This says -0.8, it's kind of messy. So this number, what it actually is, where are you getting this from? I'm not going to ask you to calculate it, but what it actually is the distance. It's a formula, but it's it takes into account the distance each point is from the line. Okay, so if you drop a line down to it, and then it does some calculations with these distances. Okay, you won't have to calculate these by hand. I will show you how to do it in the calculator, but that's where this R is coming from. It's coming from how far away those are. Okay? All right. Okay, so this problem is dealing with linear regression, which, remember from the calculator use last section, is kind of just fancy terms for a line of best fit. This talks about the age and the time spent gaming. There's my scatter plot. It's a little bit blurry. What we're going to do is we're going to make a new one in our calculators. I'm going to show you again how to do it, maybe a little bit of a different way than before, and how to come up with that line of best fit. Again, we did this last section, so we're just kind of reminding you how to do it, and I'm also going to show you the R value, the correlation coefficient. So based on the scatter plot that they've shown us, you should be able to kind of come up with a guess of your R value. The first thing you want to decide is it positive or negative? And that is simply from looking at the slope. So do we have a positive or a negative slope happening here? Hopefully you're saying negative slope. And then secondly, is it a strong, a weak, moderate? What kind of correlation are we having here? I'd say this is pretty strong. It's obviously not a perfect straight line, but it's definitely close to being a nice straight line. So I'd say maybe negative 0.8, maybe even a negative 0.9. Definitely close to 1 though. All right, we are going to figure out what that is. Maybe even negative 0.7. I don't know. We'll have to see. So get your calculators out. If you are at home watching this, you need to do part of this at school. If you don't have a TI Nspire at home, I want you to know how to do this. So write the steps down and then do it during class because you have to know how to use your calculator. Okay, so in your calculator, you want to you want to go to your home screen, go to new document. There's my steps right here. Move that a little bit. Home screen, new document. No, you don't want to save when that pops up. And then 4, we are going to add lists and spreadsheets. You guys should be familiar with entering the data at this point in 2 columns. Be sure to name each column. So here are my lists over here. I'm going to just call this one A for age. You actually can spell it out if you want to. Let's do that. We haven't done that yet. Let's call it age. We want to skip this one. This is if you're typing in a formula. We don't have a formula, so skip that equal sign box. And then you're going to type in the rest of the numbers. Go ahead and pause the video, do that, and then also do time and those numbers there. Pause the video, finish that up. Now that you have everything typed in, now we're going to make the scatter plot. Okay, so this is the second set of directions here. Control. Oh, and another piece of information here. If you leave it like this, your calculator is not going to use that piece of data. So you want to always make sure you either press enter or arrow down and get off of that so that it actually enters that into your data. Okay, so then control doc. 2, we want to add graphs. And then we're going to click menu, graph entry edit. And we want to make sure it knows we want to do a scatter plot, so option 5. Then you're going to enter the names of your data and press enter. So I named them age and time, so AGE for my X value, and then my Y value, I want that to be time. Okay, and then press enter. Can't really see anything. It doesn't look like anything happened, but it's just because it's off of my graph. My X values start at 10. I can't even, that's the first one I can see. My Y values are all the way at 85 for that, so I've got to change my window. So menu, window zoom, which is option 4, and then I want to choose option 9, data. So that's just going to zoom in on the data that we have. There we go. You can move this window around if you would like. You can click and move, you can drag it. You can also go in and customize your window, menu, window zoom, window settings. Maybe you want it to start at 0. You can make the scale count by tens if you want. Maybe you want to go 0 to 50 and count by tens. You can make it do that. So this is up to you. It's up to you what you want to do. If you want to leave it just with what they give you, that's your choice. So I'll change the X's and leave the Y's. Okay, so you can see it redid my X's. It didn't change the Y's. You can move that to wherever you feel it best shows you everything, but certainly you want to be able to see all of your data and you want it to take up most of your screen. You don't want all your data in like one tiny little corner. All right, so we have our scatter plot. The next thing we want to do is find the line of best fit. We did this in the last section, so I'll give you another reminder of how to do that. Okay, so you want to hit Control Doc, and now we want to add a calculator page. Menu, Statistics, which by the way, these are over here, the directions. So you can copy them down, pause the video anytime you want, pause it and copy it. So we're on statistics. We want to choose stat calculations. Whoops, I hit something before I wanted to. Let's go do that again. Menu, statistics, stat calculations, and we want that linear regression. There's two linear regressions. One is in mx plus b form, and the other one is not. We work with y equals mx plus b, so that's the form we want. Enter the names of your data lists, and then click OK. So our X list, its name is age, so we type that in. And then your Y list, its name is time, so we type that in. If you look what it says save regression equation to, it's automatically going to not only give us the equation, it's going to save it in F1. And we'll see in a little bit, just in a second here, why that's beneficial. So you definitely want that to be in there. For some reason it isn't, type F1 in there, but it should be there. Frequency list, we're not going to change. Category list, include categories. Leave all that alone, click OK. It pops out all of this information. If you look at it, it's saying, it's a regression equation, we're working in mx plus b. It's giving you your m, your slope. It's giving you your b, and then it gives you something called r squared, r, and resid. Guess which one of those we want? The r. The r value pops out right there for us, and it's actually a stronger correlation than I thought it would be. Okay, so this is really cool. We have all of this information. Let me put it over here so we have it. Okay, so from this information right here, I can write the equation for my line of best fit. If I'm writing the equation, go ahead and round to the nearest hundredth, so 2 numbers after the decimal. So y equals mx plus b. Our m would round to negative 1.67 x, plus our b would round to 106.89, 2 numbers after the decimal. Okay, so I kind of just like to see, does that look like it would be right? Well, my y-intercept, if I drew where I think maybe a line of best fit would be, it would be way up here. This is 90, I'm counting by tens. Yeah, that'd probably be about 106. Slope of negative 1, so you're going down 1 point, almost a little bit more than 1.5 over 1, because remember we could always put that over 1. So just a quick check to kind of make sure you're on the right page, that maybe you didn't type anything in crazy. All right, going back to your calculator screen, we want to actually put that into our scatter plot. So mouse back to the graph tab, which is probably 1.2 if you followed my directions exactly. Press menu, graph entry edit, and we're going to want to do function now. So option 1, function. Now it pops up on F2, and the reason for that is because there's already something in F1. So we have to arrow up to see F1. And if you look at what's in there, that's our regression equation. That's our line of best fit. If you press enter at this point, it's going to take that line and graph it. So now your line of best fit is on here, and it also takes that equation and writes it on your graph. You can mouse around and get it and move it if you can't see all of it. Sometimes it's pretty far off the screen. This calculator setting has it rounding these numbers automatically. Yours might not. It just totally depends on what your settings currently are. So if it's rounding, great. If it's not, great. It doesn't really matter because you can always see it up here. If you just press, if that goes away, you can always press tab to get it back. This one's actually rounding it quite a bit. It's going all the way to 107. Okay. Okay, so you're going to be asked, what does the slope mean? So here, your negative 1.67 over 1 is your slope. Remember, it's rise over run. So this is your y value. This is your x value. Your y, oops, let me move that out of the way. Your y is talking about your time spent daily playing video games. Your x is talking about your age in years. So we could say the slope means that you losing because it's minus, 1.6, approximately 1.67 minutes playing video games for every year older you get. The y-intercept, on the other hand, means that if you are 0 years old, right, because that's when it happens, you spend 106.89 minutes playing video games. Obviously, that doesn't make sense. A baby isn't going to spend 106 minutes playing video games. But if you look at your information, that number, that 0 data point is outside of your data. So that's what we talked about last section. That's extrapolation. So that's not always going to be a good indicator of your answer because it's outside of your data set. So what it means is this equation works really well for the data from 10 to 45 years of age, but we don't know that it's going to work outside of those numbers. So from 0 to 10 might not be true. From 45 up, it might not be true. So that gives you a little example of extrapolation, but that's still how you would interpret the y-intercept. And the last question you might be asked is, what is the correlation coefficient and what does that tell you? And we would say here the correlation coefficient, it is just your R value that pops out of the calculator. It was negative 0.97, it would round to right here. Is negative 0.97, which indicates a strong, a very strong negative correlation. Negative, again, is just indicating that it is a negative slope, okay, versus positive being a positive slope. But the closer the number is to either 1 or -1, the stronger your correlation is. And that strong negative correlation is telling you that as you get older, the less video game playing you get to do. All right, that brings us to residuals. Residuals, actually what they are is back here on this graph, it's that distance. Okay, and we're going to calculate those actual numbers. And then those are used in finding your correlation coefficient. But we're going to calculate those, the actual residuals, those distances, those points are from your line of best fit. The way you do that is you take your actual, where the point is, minus where your line of best fit is predicting that it would be. So here is your age and your time, and then we're going to figure out, well, these are the actual right here. This is where the points actually are. And then we're going to figure out the predicted by plugging them into the equation. So this is, again, something you were doing in the last section. Your calculator will do this for you really nicely and quickly. So if you're on your calculator graph screen, press Menu, Trace, which is option 5, and then Graph Trace, which is option 1. Now mine popped up and it's actually on the scatter plot part. It's on the points, the dots. We want it to be on the line. So if you arrow up or maybe down, depending on which point it started you at, you'll get onto your line. So now I'm on my line. The first point it jumped to, it's giving me the value right here. And I can just arrow around. Now some calculators are going to jump by different things. You might even have decimals. Mine is jumping by 3s and in integers, but I might want to know points that are in between there. If you just type in what you want to know, it will pop right up to that point. So if I just type in 10 right now and hit enter, it automatically jumps to that value and it gives me out that it should be 90.2. So I write that into my chart. Okay, the next one I want is 15, so I just type in 15, hit enter, and it shows me over here that that gives me a value of 81.9. Okay, let me show you one more. So I want my next one to be, I want to know when my x is 20, what is the y predicted to be? So I type in 20, press enter, and it gives me 73.6. Okay, pause the video and find the rest of these values. Okay, so once you have all of those values pulled from your calculator. Then to find the residual, you're going to take the actual amount and subtract your predicted amount. Make sure you do it in that order. So 85 minus 90.2 gives you negative 5.2. Okay, keep going, subtract all of these. Subtract your left column minus your right column. Pause the video, do that now. Okay, here's all those values. So what do these residuals mean? Well, this first one, our 10, came out to negative 5.2. So at 10, oh, I don't have it. Let me see over here. At 10, we're saying that our line, let me line that back up. Our actual value is negative 5.2 units from the line. At 15, this next point, our actual value is negative 6.9 units away from the line. At 20, you're 6.4 units, your actual from your predicted value. Actual from your predicted. So if it's a negative value, that just means your data is below where it's supposed to be, and if it's positive, then it's above where it's supposed to be. Okay, the next thing we want to do is plot these. And this is really where you're going to get information. The residual plot is used to determine if a linear model is best. So we're only working with scatter plots. We're only coming up with the equations when they're linear at this point. And then, so this is the residual plot is going to tell you, was that your best option? In 5.2, a couple times that we asked, do you think you should use a like a linear model, or maybe a quadratic, or some other thing, maybe something with a square in it, an exponent of 2. The residual plot's going to tell you whether or not the linear model is best. So we need to plot all of these things. If you look at your residual numbers, the highest residual number is 7.7. The lowest is negative 5.2. So right here, I'm going to list those. I need this to be my 0. And then because I need to go all the way to 8 and down to negative 7, I'm going to count by 2's here. Otherwise, I won't get there. So 2, 4, 6, 8, 10. And then here, these would be negative 2, negative 4, negative 6, negative 8, negative 10. This is my x's right here. So that is actually my age. That goes from 10 to 44, so I could count by 5's here, I think. Let's see if that fits. It's sloppily in there, but you guys get it. 45, there we go, that'll work. Okay, so what we're going to do is plot these, and when you plot these, you're actually just doing the first column, the x values, the age, and the residual. So you can kind of, don't scratch this out in your paper, I'm just doing it so we don't get confused. So your first data point would be 10, comma, negative 5.2. So 10, negative 5.2. Your next one's going to be 15, negative 6.9. Okay, pause the video and finish plotting the rest of your points. Okay, so here is our residual plot. This is kind of in between when we're trying to determine if a linear model is best. And the reason that well, let me fast forward and then rewind. Residual plots, if it's good, a good one essentially is meaning linear is the best model. And that is going to happen if you have random points all over the place. So you might have like something like that. That would be a good example of a linear scatter plot shown by the residual plot. A bad one means, hey, you probably shouldn't be using a linear equation. It's not going to be a y equals mx plus b. And that's going to look like, a bad one means there's going to be a pattern. It's not going to be just random dots everywhere. Maybe you end up with something that looks like that. Okay, some type of pattern happening and not just random dots everywhere. That's indicative that it is not a linear scatter plot. So looking at our residual plot here, you can kind of see a bit of a pattern. Okay, they're not super, super random. And the reason that you're getting that is because, pull up my calculator screen. It's because right here, because that curves up right there. But I still think a linear one would be pretty good. Linear one would be a good model here because we do still have some mostly random versus a pattern. Okay, so if it is a random residual plot, that means you do have a good linear model. And if you have some type of pattern, whether it looks like that or let me do a different color, maybe something like this. They don't have to be perfectly lined up, but see how here we definitely have a pattern happening of kind of like this shape. That's going to tell you that you don't want to use a linear equation for that. I know it's a long video, but it's a lot of stuff in your calculator. Calculators are awesome. Make sure if you watch this video at home without a calculator, you get your butt to school and you do it in the calculator so that you know how to do it. All right, guys, have a wonderful day.